Good morning, everyone. Welcome to today's daily. So we've made this little sci-fi car generator. It's a little rough, but it was a good learning experience. So we have this little generator where we can just start with a simple shape, slap some wheels on it, kind of create some visual interest, and then generate a bunch of variations, something car-like. I don't know if I can say that it is a car. uh, I feel like there's a few features that we would really need to add: windows, doors, maybe a grill, and things like that. Um, but this is a step towards it. And I think I will return to this car generator at some point. So the GeoNode over here, we have a seed which we can just slide through and see tons and tons of variations. We also have this mirror, which is what's giving us the symmetry. You'll notice that there are some degenerate results in which there's like two sides and nothing in the middle. That can happen pretty easily, or something like this where it's just disconnected. So obviously we wouldn't want that. But still gives you tons and tons of variety. I like this one over. Oh, I guess I lost it, but yeah, I like quite a few of these. Yeah, this one's cool. And I think with a little bit more art direction, finding the right shapes and stuff, you could get tons and tons of cool variety. So for the actual geometry node, we have the seed, which just plugs in a number. You get a random output. Looks pretty good. The X and Y determine the size. So we can kind of squish it down. We can make it longer, wider, shorter. You get the picture. That looks cool too. We can also change the color of kind of the hull there. So we could get something a little bit, I don't know, more sci-fi looking. I like this look. And then we can change the count on the sides. So at its core, it just starts from like a simple grid. So the X and Y count for the sides. So if we go down, get fewer variations to the point where there is actually nothing if we go to 1, because this one gives us just 2 lumps to start from. So we're just kind of playing around with just these 2 sides. A little more complicated than that, but we can get a lot of variation. Again, just super rapidly. Bada boom. Looks cool. I'll probably label those. The graph is a bit of a mess this morning. This is definitely much more of just like research and experimentation. I would not consider this a finished geometry node, but still a great learning experience. And I think you really could take it and make whatever you want from it. So let's jump into the graph, figure out what's going on. Okay, so just like I said, we do start with a grid. To make that grid, I'm actually using these curved lines right here. So we start with this single line right here. This is our very beginning, and I'm gonna get rid of that cursor too. So we have this line, and then what we do is we can resample it. So that's the count. So we start with the line. We can change the width of that or the length of it. We can change the amount of points that are along that length, and then we can do curve to mesh and use a second curve line along that mesh. So we have one curve, and then we run the length of the other curve along it, which makes a square. As long as there are straight lines, you get a square as a result. And then if you extruded it again, you would get a box. So quite cool. I think there's a lot to that actually. I actually think that this, using the curve lines to create your primitives, like a square or a cube, is probably better than just starting with a grid primitive, because you can use curve factor, which is very important and a very useful attribute to have. Other than that, you would just store position values as kind of a factor. Anyway, so with those two, we can see that we have our group input for the Y length and the X length. What you may notice is that this is actually offset. So if I go to The top view, you can see we're only making one side. And I think it's a little simpler. We're using the mirror at the very end in order to create the symmetry. We really don't. The cool thing about symmetry is it makes things look intentional, even if it's super chaotic beforehand. So you can have all this noise, you symmetrize it, and your brain goes, oh, that's a thing now. Kind of a hack, which I like. Okay, now the first main step here, we'll organize this as we go through it. First main step is deleting. So what we do is we use delete geometry, and we have this random value, which we're changing the seed of. I could increase the probability, and in the future, I'd probably attach that to the input. For now, I'm not going to, but you can see we can change the amount of deletions. Pretty cool. Then we solidify that, so we get this nice thickness right here. And there's clearly a lot more that goes on. But I'm going to go back, add this right here. So it looks nice and clean and intentional. All right. So getting into our first branch, we're going to ignore the upper branch right here. Save that for later and just focus on this one. So the first thing we do after solidifying it is just an additional solidifying. So we're extruding again. So we solidify, but we're only extruding the top. So if I go to the wireframe, you can see we have the initial geometry and then that first extrusion just on the top faces. So to do that, we are using the top from our solidify, which is just a beefed up extrude mesh. So we pass that here, and we include a random value so that we get some variation. So not all of the faces get extruded. And that kind of, as we build up these intentional randomizations, we get more and more interesting shapes. And that really is kind of a core element of procedural workflows, I would say. All right. Then we go ahead and we go here. We delete. What are we deleting again? Vector. We got the position, the min, minimum. I don't think this is necessary anymore. I'm just going to get rid of this. Okay. So skip that part. Cleaning up stuff as we go. Next thing we do is, this was my initial attempt at symmetry. Did not come out very well, so we'll also get rid of that. My control X isn't working. X. And I am an important note for anyone that is downloading these regularly. I'm in Blender 5 now. This is not Blender 4.5, it's Blender 5. Okay. So now we've got this little chunk of extrusions encapsulated, and get rid of this. Now we're at the next part, which is subdividing it. So again, we went through all those extrusions, got this nice, interesting shape. Now we're subdividing it to get some smoothness, because cars are not perfectly boxy. They can be boxy-ish. We could even add this as a parameter if we really wanted to include some control. So we do that, and then we separate randomly, because we want to add some kind of greeble, if you're familiar with the term, which is just like randomness, again, endlessly. And so on that first section, we instance on these faces a small component that I made, this little panel right here. So for every face, we're taking this panel and just attaching it, and it looks pretty good. Nothing too crazy there. We could add more panels if we wanted to. I'm not going to do that right now. For the other direction, our inverted selection, we subdivide that again, extrude it so we get these nice panels, and then we set the mesh normals using the, excuse me, goodness, set the sharpness, and we use the side as the edge sharpness in order to make a nice sharp edge. And that looks a lot nicer than it would otherwise. Then we store some vertex colors on there and eventually set the material down the way, but we're not going to do that, get to that just yet. All right. So that is the first side, kind of the hull of our object. We get this as an end result. Again, we symmetrize at the end, so it's okay if it's a little asymmetrical right now. But let's go back and look at, goodness. Man, Blender could use a little bit more tuition on, yeah, doesn't matter. All right, the other path. So where did we separate? Again, we separated at this little block here, and we went to the top and we deleted everything but the side that's pointing towards positive X. So we use this new node. This is a standard node now in Blender 5. What's pointed in the X direction? We get those, delete everything that's not those, and then we separate again. So what this logic here is doing is we're looking at the position of all of our faces. We're finding the Y position, and we're going, hey, for the min and max, we'd like to select both the minimum and maximum faces that are facing X positive direction. So find those, and then delete everything else. So we do 2 deletes because we want 2 positions for the wheels, right? We're on one side of the car. We want 2 positions, front and back wheels. So we get the frontmost face and the backmost face on the X positive side. We do one more little cleanup here. This is delete extra, which is just deletes extra faces. Basically, it looks at the X direction now, and whatever is the maximum X direction it keeps, gets rid of the rest. So, for example, I believe, well, yeah, anyway, so it cleans it up. So we get just the one face. Looks pretty cool. If I show that again, you can see the face. We take both of those, combine them together, and then all we do is instance on the mesh. So we take all the faces, which is just 2, right here, take these 2 faces, turn them into points, and on those points, we instance the wheel object. We use this sample nearest surface right here in order to sample the normal, so we can align the rotation direction of our wheels with the face. We also do one more rotation afterwards because they were just facing inwards. And yeah. Oh yeah, and then this transform right here creates the other wheels. So we have the rotate instances. These are our tires. And we flip them, join them. Now we have 2 sets. And we join them all the way at the end. Bam. Realize the instances. So it's mesh. Join them together. Set the material. I don't need this join. It's not doing anything. Now at the end here, we're just centering things. So what you can do to center an object, take the average position of everything, subtract the negative version of that position from the position, and it'll snap it. Then we do one more snapping, which takes the bottom of our object. So that will, let's go through it. So we have our mesh, we center it, and then we snap it up. So the tires are touching the bottom right here. There you go. That's pretty much it. Nothing too crazy. Hopefully you find this kind of educational, or at least entertaining. It is a little bit rambly today, Monday, so forgive me for that. But I'm quite excited. I think this kind of same methodology could be used to make like carriages. I could think of like vegetations, or like you imagine a marketplace, medieval marketplace, like the stands that are there, where they have like fruit you could purchase, something like that. Something that needs a little bit of structure, but enough variation to look novel. Buildings, all of these rules that we used are very general. Nothing that's specific to cars for the most part. Really, kind of the core logic is one shape with variation and placing an object on corners of it, the wheels. So yeah, thanks for taking a look. I'm going to go ahead and upload this, and maybe sometime later this week I'll try to make some udon scripts so these can be drivable, at least like in an RC style. Make a bunch of different car variations and then let you drive them around. I think that'd be a fun experiment. Okay, thank you again for taking a look. Hope you all have an amazing rest of your day. See you in the next video.